But in this, I'll be performing a advanced dimensionality reduction collapse, where I'll be performing two main activities in this. First one is any image dataset and the tabular dataset. Like I'll take one of the dataset and try to perform the PLLE, t-SNE, and the dimensionality reduction techniques, that is PCA and kernel PCA and etc. And post that, like I'll be performing advanced dimensionality reduction using the Databricks and other tools. So let's go to the image data, where this is the image data set, like where I have installed the packages from this, and that is UMAP and the Plotly, and the second is from OLITI face detection face data sets. So I have imported this, and this is the loading and visualization of the label 0, label 1, and other two as goes on. And here is a pre-processing of the data and standardizing the data, and from here onwards, like we'll apply the dimensionality reduction techniques. First one is PLLE and t-SNE is this one, and post that Isomap is also similar to that, like Isomap, and post that like UMAP is slightly different from that one, and multidimensional scaling MDS. So here is the loading of the multi-model one, and here is a plotting of that, and here is a dimensionality 2, dimensionality 1 versus MDS, and here is the randomized PCA, and for here is loading the PCA commands, and here is a scatter plot for that, and plotting for that, and that is randomized PCA. These are the graphs for that, and this is the kernel PCA one, and where my data doesn't have the much value for the kernels, because it has only low data set, so that's why it was able to plot only 4 or 3 data points in it. And this is the incremental PCA. So in the incremental PCA, the data are scattered over all the figures, and this is the factorial analysis same performed in this. So, and this is the autoencoder, like I'll be performing. So here the defining the autoencoder, and we have to take the input wise, and this is the ReLU and sigmoid autoencoder. ReLU is the encoder, and the sigmoid is the decoder for it, and input image, and here it will be encoded to that. And these are the compile encoders, where I use the binary cross entropy for training conversion. Like I created around 50 approaches for this, and this will be performed in this. And here is the extraction of encoders, where 13 by 13 of 3 millisecond per steps like will be performed here. And this is the final visualization of the autoencoder results, and here is the model for us, and etc. Here is a dimensionality reduced model, and this is about the dimensionality reduction for 450 faces data set. And next we go to the tabular. So basically, like I'll be performing both the same task, like, but here like I use a tabular data set which is exactly equivalent to the breast cancer data set, where I'll be performing the same, importing the libraries and loading the data. So basically we can see the mean radius and measure texture and all the data set. The breast cancer data set looks like this, and applying the PLLE is this one. So after applying, we see the target dimension and dimensionality 2, and the t-SNE. After that, we see the plots as here. It was basically it was all combined. So here we can see the differences of the scattered plot, and here is Isomap also performing the same. So it again separating them, and UMAP is also separating them via these values. And PP in the MDS is also kind of similar data, where I have used a MDS model and importing and some kind of plotting task, and same performed in both way. And for randomized PCA also, like I did the same, and for kernel PCA also performed the same task as goes on for the incremental PCA. And once it's done, then the factorial analysis is this one. So factorial analysis is this one. So I'll be performed. So post that the autoencoder and defining autoencoder and input for the input layer and the encoded, that is like I use a sigmoid. So compile autoencoder is this one, like Adam, and mean square, like here, like for the loss, previously, like I have used a cross entropy for the image, and for this, like I have used a mean square error. So this is the training hypothesis of the batch 50, and post that the model will be turned into 18 by 18 but 2 milliseconds per step, because it's a data which are in tabular, it's easy to load and etc. So this is the autoencoder plot. And at the last, where we go to the dimensionality reduction using the Databricks workflow. So this is about the PySpark SQL and feature lingang and the vectors and other PCA and other tools, like I'll be importing from this. And here's the dataset, and again I'm using the same breast cancer dataset for this as a target variable, as a name as a target, and the converting Spark to data frames. So this has been performed here, and post that the processing, the pre-processing, or that is standardizing the data set. So this is the one, and after that randomizing the PCA PySpark and PySpark for SpyPark PML PCA, where it will be loaded. So assemble, and autocall is the features like I'll be using in this. So applying PCA in a PySpark, where for input column, like I'll be using the features, and for output column, like I'll be using the PCA built-in features. So and here is the like approach for this, and post that, like I'll be adding the plots for the t-SNE and like all the other listed things. This is for UMAP, and yeah, it will load sometime. This for UMAP, and these are the like combining this for UMAP, and these are the model like I will like combining TSO, MDS, and all other thing. So this is the one. Okay, it just a second, it will load in a moment. Yeah, so it will be making 50 plots in it, and once the 50 approaches are performed, then like I'll visualize like how the graph is exactly looks in this. Maybe like it has a cursor, like I didn't like I can run it. So, yeah, this is the autoencoder of the one that works. Like here is the like left identify targets, and here is the scattered all over the red targets. So this is all about the advanced data dimensionality reduction. So thank you.